to the chemical state of our soils, which also interact with our biophysical states of our soils. All of these components of, as I understand it, biological, physical, and chemical components of soil, they all are important. They all interact with each other to actually deliver petogenesis, which is soil development. And it's interesting because really what we have on campus landscapes is not soil, it's growing medium. So it's a form of engineered soil. So there's this question floating around of whether these are the data attributes that you should still apply to growing media, or whether there's something else that we can sort of assess in our growing, would there be a separate approach for soils that are not, from millennia ago, but rather engineered growing media that has been purchased and can be amended to perform as soil would. Is it the same value? Is it the same worth? These sort of questions do arise, and I think make the matter a lot more complex, and something to explore in the discussion after this for sure. The third thing that came up was Earth-system interaction. So how do we understand the soil as something that delivers its service by performing and functioning with other parts of Earth's spheres. So Earth has a lithosphere, a hydrosphere, an atmosphere, and a biosphere. And soil is, the reason soil is known as the Earth's critical zone is because that's where all of these spheres come together. How do we, do we include this in our measurement of soil performance? Are there only certain aspects that we include? And so some of the data points that came up there was, you'd be measuring evapotranspiration, you'd be measuring rooting depth, you might monitor carbon levels in soils to really get a sense of carbon sequestration in order to map out these relationships. And then the other thing that came up was soil maps. We really need to understand, I think at a very basic, this is probably the most basic but most necessary and therefore the most achievable goal is to have soil maps that kind of list out the order of the soil, what their parent material is, and what characteristics they hold. And I wouldn't be surprised if all of our soils were podzolic soils, because that's what's found at UBC's farm, but that might not be the case at all. And I'm not the expert on soils here. So, without further ado, let's move on to the discussion portion of this. This is a bit more interactive, and ideally, if there are, an equal number of staff members and academic experts on the table here, if one academic can partner up with a staff and therefore exchange some views that enable both parties to understand each other's perspectives, that would be great. But essentially what would be great is if you could take a minute to peruse through Table 1 and sort of discuss what you would identify as the top 3 priority data attributes to measure. And this can be on the criteria of, well, what's the most achievable data attribute to measure, or rather, what's the most important data attribute to measure and I know that this is a tricky question because there isn't one most important data attribute, but perhaps maybe discuss what sort of criteria you would select priority data attribute by. And then if there's time, what are some challenges you foresee with mapping these attributes in our campus soils? And this, I think, will really help both sides explain their view on what needs to be done to advance sustainable soil management on campus. So hopefully we have enough time for that, perhaps around 4 minutes, I would think, 4 to 5 minutes. And then for our next steps, I'd like to discuss that with you in our Q&A portion. And that will relate a lot more to the desktop research that I am now currently doing. Thank you for your time. I'm sorry I can't be there in person. Enjoy the discussion. Thanks.